Hello everyone, welcome back to my class. So today we'll be talking about choosing the appropriate methods for expanding and factorizing algebraic expressions. So we're going to start off with expanding today. So when we look at our expressions to expand, we just want to think, what are the particular methods that we've looked at so far, and what order we want to do things. So generally we want to use our expanding pattern. So we've got our perfect squares, which can be a negative or a positive in the bracket, changing the sign of the middle term. So that's perfect squares. And then we've got our difference of two squares expanding pattern. So the same numbers in the brackets, just with a different sign in each, and we get the squares of both of those numbers. So that's the difference of two squares. So I'm just writing little acronyms for short. And then we've got a third method, which is just the generic distributive law. So there's no pattern involved, we just expand the brackets. So if we have two terms in each bracket, it will just turn out to be FOIL. So we just FOIL that. Okay, but this can be more than two terms per bracket, so it can be a single term per bracket, or we could even see up to 3 terms per bracket. So these are all likely expressions that you can see. All we do is we just look at the number of terms in each bracket, multiply them together, and we result in the amount of terms that we're expecting to see at the end. Okay, so the best way to look at this is just to see a few examples. So we'll start off with our first example today. X plus 4 times by x plus 7. Okay, so I can see that it doesn't follow any of our expanding patterns that we've seen so far. So it's not just a single bracket of numbers of two terms and a square. And it also isn't a difference of two squares, because one, we have the same sign and we've got a different number in the second position. So we know that we just need to use the generic distributive law, and in this case we'll be using FOIL because we have two terms in each. So we just multiply out the first term, the outside terms, so that's x times 7, so 7x, the inner terms 4 and x, and then the last terms, so 4 and 7. So we'll get x squared plus 11x, collecting the like terms x and x, so they have the same variable, and then 4 and 7, which would be 28. So that is now fully expanded. So we'll have a look at our second expression. Okay, so we have n minus 3, n plus 3, take, n minus 2, n plus 3. So we can see that we have a difference of two squares here because we have the same numbers in the same positions in both sets of brackets, and we have a negative and a positive sign. This one is almost a difference of two squares. The only thing is we've got a 2 here and a 3 here in this bracket. So this one is just going to be the generic FOIL. So this one's going to be FOIL, and this one's going to be a difference of two squares. So we'll expand these out. So we know difference of two squares is just going to be the difference of the squares of the two numbers. So the first number is a positive, and the second number will be the negative. Okay, but we can't forget we've got a minus here in between. So this is effectively minus 1 times all of this. So we can't forget about this. So I'm just going to put a big set of brackets there, because that way we don't forget about this minus. Okay, so if I just use FOIL on this, similar to before, so I'll get a positive 3n and minus 2n negative 6. Okay, then I'll just simplify the first bit, and then I just want to collect like terms before I move forward. You can just do these next two steps in the one step if you like. So I have n squared take 9, and then I have a negative timesing, so that's effectively -1 multiplying a bracket of n squared plus n minus 6. So all I do is I just change the sign of each term inside the bracket. Okay, so I have a -1 multiplying n squared. So this also follows the distributive law, because we have a number multiplying a bracket. So that means I need to times that -1 with all terms inside the bracket. So all that changed was the sign of each number, because all I had was a -1 multiplying the bracket. Now I can see that I have two n squareds where one was a positive, one was a negative. So 1 take 1 is equal to 0. So they cancel out. But I have a minus n and then a -9 and a positive 6. So that becomes minus n minus 3. Okay. Cool. So we'll do the final example now for expansion. So we'll look at 3x plus 5 take x take 3 all squared. So what we do is we look at what expansion we can do first. So I can see that I have a bracket with two numbers inside with a square. So that tells me I am looking at a perfect squares expansion. So all I'm going to do is just leave the first part of this expression alone. And I've got a negative sign in between. And once again, I'm just going to put a big set of brackets. So the brackets can be they can be a square bracket or a curved bracket. I tend to just use a square bracket when I just want to separate out my equations, because that makes it nice and clear. So that the shape does not matter. So perfect squares. So I know I'm going to have this pattern because I have a negative inside my bracket. So I know I'm going to have a negative here. And I'm going to have my first number out the front squared and in my middle term. And I'm going to have my 3 in the middle term and at the end as well, squared. Okay, just that, following that perfect squares formula. So the front stays the same, I'm not doing anything. All I'm doing here is I'm just simplifying my middle term and the end term. Okay, now same as before, I now want to expand this bracket here. So once again, I effectively have a -1 multiplying everything inside this bracket. So all I do is change the sign of each term in my bracket. So you can see that there was a positive here that turned to a negative. There was a negative in this front of the second term that turned positive, and the positive in front of the last term turned negative. So I make sure I change because that's more, it's got to multiply each term inside the bracket. So that's why they all need to change. Then I collect like terms, so there's no other x squareds. There is two x's, so I need to collect those terms, so that becomes 9x. And I've got a plus 5 and a -9, so that becomes -4. So that is all finished. Now, so we look at the factorizing methods for today then. So basically we're following the exact opposite process of what we just did. So we're looking at we're looking for taking out a common factor first, so the highest common factor first. So this is effectively equal to the last step in expanding when we just collect like terms. So in factorizing, we want to take out the highest common factor first. Second, we want to factorize using our difference of two squares. So DOTF, difference of two squares. So that's going to look like this. We factorize down, just the exact opposite as before, or perfect squares, where we have this pattern, or we have a negative in front of the second term. Okay, and if we can't do either of those, so if those can't be done, we use the sum and product, which looks like this. P plus Q, X plus PQ. Okay, so we'll do a few examples. So if I have an example that looks like this, so first of all, I'm going to take out the highest common factor. So that means numbers as well as the variables. So I have a -2 here, -4, got an X and an X. So I need to take out at least a 2 and an X. Now I also have negatives here, so when we can also take out the negative as well as the numbers and the variables. So that just simplifies it down even more, because we want the most simplified versions. Okay, so if I divide each of these terms here by -2x, you can see I'm going to cancel the -2, the x, the -4 goes to +2, and the x, okay, and the y is still there. So that is why I have y plus 2 inside the bracket. Now you notice that we've actually finished here. We don't need to do any more factorizing, because that's all it took, okay? That's as far as we can go. So we don't always have to use the more complicated factorization patterns, okay? So just take it as far as you can before you need to stop, okay? So we've got our next example. So we've got 72, take 2x squared, okay? So what we do is we take out our highest common factor first. So we've got 72 and -2. So I can see I have a factor of 2 in each. So that becomes 36 minus x squared. Okay. So now I see that I have a squared number and a squared number with a subtract sign in between. So I know I'm looking at a difference of 2 squares. So we have a 6 squared and an x squared. It doesn't matter that the x is in the second position. We're just always looking for that pattern. And the 2 is just staying out the front. So all I do is I place 6 in the first position. And then I have my x in the second position. That red. And I have my 6 and x again, just changing the sign. Okay. Then we can just simplify it down to the final answer. Okay. So last example. So we'll be doing x squared plus 23x plus 60. Okay. So this time, cool. So when we look at this, we can see that we don't have a square number in the first and last positions. So x squared is a square number, but 60 is not a square number. Okay, so that tells us it can't be the perfect squares pattern. And we also see that it is not a difference of 2 squares where we're looking for 2 square numbers with a subtract sign in between. So we know we're looking for a sum and product. So when we do sum and product, we need to find the factors of 60. So I'll just write them out now. So 4 times 15. Okay. So I can stop here because I know they need a sum to 23 and multiply to 60. So I can see that if I have +3 and +20, they will sum to 23. So now I can go straight to putting my x's in brackets, and all I do is just fill in the brackets with these 2 numbers here. Okay, cool. So that's it for today. Thank you for listening.